compound interest. So I am going to do one problem quickly for you. Number 2, the issue was that the equation needs to be P times 1 plus R over N times N to the T. So this one would be $780 times 1 plus 0.075 is my rate, divided by compounded monthly is 12. And I'm going to take it to the power of 7 times 12. And my answer is going to be $1,316.41. So again, what I forgot to show you yesterday was taking it, dividing it by how much you're compounding it. This one was monthly, so we had to divide it by 12. Making sure to do that right. Okay, so today we are going to be looking at half-life doubling compound interest notes. Okay, the half-life of this substance, which I can't pronounce, strontium 90, is about 29 years. So the half-life of strontium 90 is about 29 years. This means that half of the substance will remain after 29 years. We're going to write an equation that represents the decay of 500 grams of strontium 90 over time in years. Use a base of 1/2 for this situation because it's half-life. This is considered a discrete change variation, so we're going to use y equals a times b to the x. So what is my initial amount when I first start? 500. The strontium 90, it's not 90 because that's just the name of that substance. So don't let the number freak you out. So that's A. So right here I've got 500 equals A. What is B? It tells me what to use. 1/2 equals B. Okay? And then, so we're going to go 500 times 1/2. And instead of x, we're going to go x over 29. Because it tells me my half-life is 29 years. Questions about this? All right, let's plug in if we have 15 years. So we go 500 times 1/2, 15 over 29. What do we get, guys? Let's plug that into our calculators. What am I getting? I'm getting 349.353 what?
Years.
Not years.
Grams.
Grams. Good. Okay. So this one's a little bit more confusing. What is the percentage of the substance that remain after a year? So we're going to figure out how many grams we have, and then we'll figure out the substance, okay? The percentage, excuse me. So I'm going to say 500 times 1/2 over raised to the 1 over 29. And what do I get, guys? 488.191 grams, but it doesn't ask me for the grams, it asks me for the percentage. So what am I going to divide it by? 500, because that's how much we had initially. And then once I divide it by 500, I get 0.976. So let's round it up. Or we can just change it to a percent. So now we times it by 100. So it's 97.6%. Does that make sense? How we found the percentage? Okay. Now we're going to look at doubling. Okay, so we're going to look at this general equation. The equation R equals the initial amount times 2 raised to the t over 4 gives the relationship between the quantity of r and the time t in hours. What does this equation tell you how the amount of information is changed over time? What's happening over time? Is it getting smaller, bigger? What? Instead of being in half, it's what? Doubling. Good. It's doubling over time. Okay. Now, we're going to point this out. I'm going to rewrite the equation. R equals the initial amount doubled t over 4. So how long does it take something to double? And where is it shown in my equation?
4.
It's 4.
Is that a 2 or 7?
4 hours, because we're in hours. Because it told me that t was hours right here. 4 hours, and it's written right here. Okay? So, after 12 hours, by what factor has the information grown? So if we say r equals r, the initial amount, times 2, we plug in 12 over 4, what does this become? A factor of 3. Because 12 divided by 4 is 3.
So it's tripling?
It is not tripling, because if it was tripling, that would be right here, right? It's just telling me that for 12 hours, every 4 hours it doubles.
Oh, okay.
So it's telling me it doubled 3 times.
Yeah, I get it.
Yeah?
Yeah.
Okay.
I'm getting it.
All right. I said, so this is telling me every 4 hours it doubles, right? So if I go 12 hours, I know it doubled 3 times. Does that make sense? I feel like I'm talking in code. Okay. Then back is a partner activity. Okay? That I need you guys to, I know we don't have that much time. So what I'm going to do is I'm going to split up some of these numbers. Okay, so the partner activity on the back. If you are on like Maya and Gabby's side of the table, you're going to do the odd ones. If you're on JR and Bryce's side of the table, you're going to do the even ones. So Michelle and Nolan pick. Kyle and Cassidy, I would move to the same side of the table, and Brittany and Kevon move to the same side of the table. So you can do it. And Ethan, I want you to work with Nick, please.
All right, I'll work with you.
Okay. So I am going to 1, 2, 3, 4, and 5 are all the new problems that I talked about.
So you got
6, be careful. 7 is one of the new problems. 8, be careful. And let's do 9 together so that everybody has the same amount. Okay, so we're going to do this last problem together, and then you're going to work with each other. You just deposit $1,000 in an account that pays 5% annual interest. Find the balance after 1 year if the interest is compounded with a given frequency. So we have 1,000 is my initial amount, times 1 plus 0.05 divided by 1 to the first, right, if it's annually. How would this change if it's quarterly? It would be 1,000 times 1 plus 0.05 over 4 to the 1 times 4. Good. If it was daily, what would it be?
Over 365.
1,000 times 1 plus 0.05 over 365 to the 1 times 365. Okay? All right. So now you're going to work with your partner. You're going to come in and check your answers before you pick up tonight's homework. And that's it.
I already picked it up.
Good. You have to do the partnering first because it is worth 10 points.
Or-